Hello friends, myself Sorokia Ramesh, and today we are going to learn how hemming code works in networking. So first of all we start with the hemming code. Hemming code. Hemming code is sender side. What is hemming code, how it's work, an example of hemming code we can see later. So let's start with what is hemming code. Hemming code is a method which can correct only single bit error. It cannot correct burst error. If even type of bits are changed, we cannot find error in data. So let's start how it works. In error correction, first step is to find how many redundant bits are added with data. Here data known as a message. We have to specify the type of parity which we are using. Suppose we are using even type of parity or odd type of parity, that calculates the real message. Redundant bits are placed at position 1, 2, 4, 8. They are 2 of 0, 2 of 1, 2 of 2, 2 of 3 and respectively. Suppose we have data m number of bits, so redundant r number of bits are added with m. So our original string will be m plus r. To find how many redundant bits are added with data, we have to use following equation. The equation is m plus r plus 1 greater than 2 raised to r. So less than 2 raised to r. Here m equals to data means message, r means redundant bits. Suppose it start with 1, 2, 3 up to n. If above condition goes true, we have to select that r value. Means r value we have to that r value we have to select. Else we have to increase r value respectively go up to where condition goes true. Let's take an example of hemming code. Suppose we have data like 10101001 7-bit data, and we are using even type of parity. So here m will be 7, m equals to 7. So our data will be 10101001. We can arrange with in a sequence number 1 to 7. M will be 7. We have to find how many number of bits, redundant bits used in 7-bit data. So we have to count how many redundant bits are added with data. With the help of same equation which we previous saw, m plus r plus 1 greater less than or equal to less than 2 raised to r. Here we can see r equals to 1. We start with r equals to 1 and we are proving that m plus r plus 1 greater than 2 raised to 1. This condition we are checking less than, this condition will be true. Our message will be our message was 7 bits and 4 redundant bits are added to check check and correct single bit error. So our 20 will be first position, 2 raised to 1 will be second position, 2 raised to 2 fourth position, and 2 raised to 3 eighth position. Our original data was 10101001 and 4 redundant bits are added. So our total string will be 11 character. So in the figure we can show that R1, R2, R3 and R4 are added at the position number 1, 2, 4 and 8 respectively. Now we have to find value for all 4 redundant bits with even parity. Even parity means we have to count number of 1 with even number. R1, R2 and R3, 4 redundant bits we have to find. To find value of all redundant bits, we have to use binary table. In the shown figure, we can show binary table is available with 0 to 9 values with 4 digits. So first 0 start with 000, 1 start with 0001. So to find R1's value, we can use in the R1 column, we can see number of ones are available. In the shown figure, we can see that here number of ones will be there. In the first 3rd, 5th, 7th and 9th, respectively 1, 3, 5, 7 and 9. So our R1 will be 1, 3, 5, 7, 9 up to go to message size. If our message size is 15, so we have to go 1, 3, 5, 7, 9, 11, 13 and 15. We have to include that. We must have to neglect first element for R1. So we have to first element to neglect. So over here 1 will be neglect. We start with 3, 5, 7 and 9. Okay. Now we have to look up in our redundant data bit table to find all the values. R1 is 3, 5, 7 and 9. So our redundant bit table is there. We can identify from values from there. So our third element's value is 1, fifth element's value is 0, seventh element's value is 0, ninth element's value is 1 and 11th variable value is 1. So our R1 will be 3, 5, 7, 9 is 1, 11, 1, 0, 0, 0, 1, 0, 0, 1. Now we can need to count number of ones. If total are even, then R1 will be 0 or else R1 will be 1. We can see that in R1 we can see that three number of ones are there. So 3 is not a even number. We have to convert it into even number from odd. So we have to add 1 to convert it into even. Same as we can see that R1, R2, R3 and R4 is counted same as R1. Here we can see that our original data is 10101001 and 4 redundant bit with data available. So R1, R2, R3 and R4 added at the position number 1, 2, 5, 1, 2, 4 and 8. So standardized string will be all redundant bits with value R1 equals to 1, R2 equals to 1, R3 equals to 1 and R4 equals to 0. Thank you.